All right. When you get to part 2 of the lab, uh, we're going to study how changing the system mass affects the acceleration. So the acceleration depends on the independent variable, which is the system mass. So you're going to do the same experiment with the Atwood's machine, changing the mass from 400 grams up to 800 grams, as you see here. But that means you have to hold something constant out of the three items, right? Net force equals mass times acceleration, which means that if we're adjusting the system mass and as a result changing the acceleration, then we have to hold the net force constant. All right, so make sure your hanging mass does not change. Well, if you got 60 grams as your hanging mass, keep it 60 grams for 400, keep it 60 grams for 500, keep it 60 grams for 600. System mass, keep changing your system mass, but don't change the mass hanging. Now, when you graph your data, you should get something that looks approximately like this. And what I just want to point out is that this is not linear. You need to go into your curve fits, and it's actually inversely proportional, as I'll show you in another video in a second. That is a beautiful curve you got there. And notice down here, we have our y equals a over x is our equation. And the value for a is 0.389, right? And that is going to carry some special significance. We're going to talk about that in the next video. So make sure you have your graph as inversely proportional and then grab your equation as shown.